Okay, you have two tests coming up. The first one is graphing test, and the graphing number 3 is exactly what it is. And then the one after that is communication. All right? The graphing test, just see if you would be able to handle a question like this one. Let's say that I had given you this equation, 7x cubed plus 6x squared minus 4. You should be able to tell me all kinds of stuff about that. You should be able to tell me where the left end will be, where the right end will be, and you'd be able to say it using limits. So make a sketch quick first, and then see if you can write the answer for this left end and right end using limits. I'm going to pause for a second while you do that. All right, by now you should have been able to say lim of the function as x approaches infinity. That'd be on the right side, by the way. Here. Okay, yes, I can draw the picture for you. Since this is cubic, I know it has to be going opposite directions on each end. Since it's positive in the front, I know it's going up on the right. And then what it does in between is hard to know for sure, but I'm just going to make a sketch like that. And I know that that's got 2 turns and therefore would be about degree 3, or maybe 5 or 7. But anyway, that seems like it makes sense to me. Do you agree? Oh, y-intercept. I didn't have this one as one where you had to have accurate y-intercept, because think about this. If you just need the limits, do you care what happens in the middle? As long as you know where it goes at this end and this end to write the limits, you don't need to know what happens in the middle. But you're right. If I wanted to be more careful, I could say that the y-intercept has to be where x is 0, and in that case, that turns out to be -4, because these two parts would cancel. So I agree, good idea. I should probably go through -4. So I'm going to back up and just say, okay, fine, I'll go down through -4, and then go up and down. All that really matters, though, for limits are the ends. All right. Now, you should have said limit of the function as x approaches infinity. That's the way on the right would be infinity. And then on the left side, that's where x approaches -infinity, and that would be way to the left, and that's going to be -infinity. Raise your hand if you had those two right. Okay, good. Then you're getting the limits part, which is good. Next, I'd like to actually do some graphing. So here is, and I know you don't have graph paper, but I want you to give it your best shot on regular paper to graph this. Remember, listen. Remember, if you're graphing 1 over x squared, you have to remember that that's the volcano function. Okay, so let's try this one. 1 over x minus 2 squared, and then plus 2. If you had to graph that, give it your best shot. Remember, if it's a graphing test, XY charts are your friend. They help you make sure you didn't shift the wrong way. Now remember, this starts out as a parent function of 1 over x squared, which is like x to the -2, which is the volcano-shaped function. I would start with asymptotes, because the asymptotes are going to kind of tell you where to make your volcano. All right? So where are my vertical and horizontal asymptotes? Again, on the graphing test, we wouldn't say identify the vertical and horizontal asymptote. We would just say graph it. But they will help. The verticals are the zerticals, x equals things, and they're the things that make the bottom 0. What would make the bottom 0? 2. So if you have x equals 2 being an important line, you were on the right track. Raise your hand if you were correct on that. Okay, good. Next part. The horizontal asymptotes are the horizontal asymptotes. Y equals things. And who tells you why? Bob tells you why. Is this bigger on bottom? Yes, it is. And so remember that Bob is no longer a 0. Bob is whatever's on the outside here because it's moved up 2. It's not y equals 0, it's y equals 2. Bob is an outsider, whatever's in the outside of the fraction. If there's nothing out there, you say he's y equals 0. All right, so this is y equals 2 because there's a 2 on the outside. And now the volcano will basically goes like this. That's pretty close. Now, exactly where should it be? Well, I should make an XY chart to make sure of that. Make sure I didn't like shift it the wrong way, or maybe I should flip it or something. So I'm going to find some points on the XY chart. Now, don't just do this blindly. Think about what numbers might make sense. One number I don't want to use is 2, because if you think about it, if I put in 2, that's already, we know that's an asymptote. It's not going to work. You end up with 1 over 0, impossible. Okay, but how about 3? 3 sound smart? So I'll stick in 3. 3 minus 2 is 1. 1 squared is 1. 1 over 1 is 1. 1 plus 2 is 3. So I put in a 3, I get a 3. So 3 comma 3. Over 3 up 3. See that spot right there? Does that make sense that that would be kind of in the right general neighborhood? And then generally, do you get that the thing should get closer and closer and never touch? That black line is a lot better than the blue line for being accurate. Do you have to have accurate points? You have to have a few accurate points. You can't just have sweeping lines in general spots. Okay, I know this point is on there. That's one of the parent points. Now, would you assume that this spot would be on there too? Okay, so then let's check and see if it is. So I'm going to stick in x is 1. Watch what happens. I put a 1 right here. 1 minus 2 is negative 1. Negative 1 squared is 1. It's going to be the exact same thing. 1 over 1 is 1. 1 plus 2 makes 3. 1 comma 3. And yes, 1 comma 3 is on there. And so yes, you'd have to have that parent point. So my blue graph would have been marked wrong. It was too loosey-goosey. My black graph would be marked right. Get how the 2 parent points are kind of important there? Okay, now do I have to have any more points than that are like defined? Nope. Yes. Yeah, from here, if these 2 points, this one and this one are correct, after that, as long as you get closer and closer to the line, you're fine. I'm not going to be like, ooh, this one's off by a half of a box or something. I wouldn't do that. As long as the parent points are good. That one make sense? Okay, let's try another one. And this one's, hopefully, I won't need to even tell you what kind of a graph this one is, what the parent was. You should be thinking, I wonder what the parent is. Three got a little weird. There. Negative 2 over x plus 5, and then minus 3. Think about the asymptotes first. Put your asymptote lines on there. Then think about if it's a volcano or a butterfly or which one this one is. John Travolta. I'll pause for a second while you try that. Okay, so this one I would have been looking for. First of all, x equals negative 5 seems kind of important. It tells you a what kind of asymptote? A zertical, yes. A zertical asymptote, vertical asymptote, and that's at negative 5. So there'd be a line like that, okay? And then what? How about the horizontal asymptote? Who tells you those horizontal ones? Is this a Bob? Yeah, it's bigger on the bottom, so it's a negative 3. It's an outsider. Remember, Bob's an outsider. It's not y equals 0 anymore. Since it's a Bob, it's a y equals negative 3. So there we go. And now, is this a volcano or not? Not a volcano. It's like this. Why isn't it a volcano? Because the bottom's not squared. Okay, I haven't finished it yet. Okay, now I've moved it down. I've moved it to the left 5, and then what's this negative do? It flips it. So it's not where I just drew it. It's going to be in the opposite spots. Up, down, or a left, right flip. This is one of those weird times where it wouldn't matter. So now it generally looks like this. You see how it could be really easy to forget one of those things? And what would have saved me? If I would have checked it with an XY chart, check a few points, make sure they're not like, wait a minute, why are they coming out over there? Okay, so let's try, what's a logical thing to pick? Not negative 5. How about negative 6? Sounds good. So negative 6, I'm going to put in a negative 6 right here. Negative 6 plus 5 makes negative 1. Negative 2 over negative 1 makes 2. 2 minus 3 makes negative 1. Negative 6, negative 1. Well, this is supposed to be negative. Look at that. It lands right there at that spot. I know I can kind of cheat because my graph doesn't have any lines on it. All right, and now I can try for another spot. Do you get that I want this spot to be on my graph? So maybe I should check and see if that actually works. Well, if this was at negative 5, this is probably at negative 4. Try negative 4. I stick in negative 4 right here. Negative 4 plus 5 makes 1. Negative 2 over 1 makes negative 2. Negative 3 minus negative 2 makes negative 5. Negative 4, negative 5. Look at that. It's right on my graph. Yay, I'm doing it right. Okay, raise your hand if you had that one right. Good. Okay. Next, let's talk about those inner limits. Sounds like an episode of the X-Files or something. The inner limits. Well, let's say that you had one of these kind, and let's say it was like this, and it had not been flipped or anything. And let's say that this is going to 5, and this is going to 3. Then tell me, what are the inside limits, or the limits as it approaches its vertical asymptote? If you ever have to piece that together, go, okay, vertical asymptote, that's this one. Limit as it's approaching that. Oh, it's approaching the inside. These are those inside limits. You have to have a little raised up plus or a little raised up minus to do this right. Remember, limits always start the same way. Lim f of x as x approaches. And it has to have an equals. And then remember, the x number goes next to the arrow, and the far right side is what y will be getting close to. This is where x will go. This is where the y will go. All right, so if I'm approaching the inside, approaching the asymptote, that means I'm approaching 5. And I can approach that 5 from which direction? Well, it doesn't matter. I can pick either one. I'm going to start from over here in, how would I say that, where x is negative. So I put a little negative up there. I'm approaching 5 from the negatives. And then when I do come from this side over here, I jump on this track right here, and it forces me, as I get closer to 5, it forces me down there, which means I would get negative infinity for an answer. Raise your hand if you had that one right. Awesome. And then the other side, lim of the function as x approaches and it equals. Always have that. And then I got to be approaching 5 from the other side. So I'm approaching 5. And from the other side, not from the negatives, from where these are the x numbers, right? I'm approaching this from the positives over here. So this is from the positives. And yes, you have to have a little plus. You can't just leave it like empty and say I meant plus. No, it has to have a plus there. And then the last thing is, as I come from over here, I would end up getting on this track, and it forces me up there, positive infinity. Okay? Those are limits as you approach the vertical asymptote. All right. Are you going to be good with a cubic regression question? So you'll be able to type that in the calculator, do cube reg, get the equation for it. Okay? After you get the equation, what if they give you, estimate the gas consumption in 1982. If they give you a date, what did they give you? An x. They gave you an x. X is our time. Time is x. Okay, if they gave you, there's going to be 462 frogs. When will that happen? Well, they gave you the y then. And if they're asking you for when, they're asking you to figure out x. All right, and if you've got it in the calculator, you did your cubic regression right, and you do the L1, comma L2, comma Y1 thing correctly, you just place the equation on the Y screen, right? What if they give you a Y number? What are you going to do? Yep, there's Y1, Y2, Y3, etc. on your calculator, and this one's already going to have the regression equation in it. If they give you a Y number, you're going to put it on this line right here. If they give you a Y is like 462 frogs, then you see where the two lines cross. With second, calculate, intersect. Yeah, but that's if they give you an x number. Okay? But I actually like better for that what I like better for that is if you've got an x number that's being given to you, then I would recommend you graph it and do second calculate value. And when you do that, the calculator pops up a little x equals, and then you type in what x is. Okay, that again is called second calculate the value. When you're working on your homework today, if you want to ask me about that one, you can. All right, I don't want to spend tons of time on that one because frankly, almost everybody gets the regression questions right, so I'd rather focus on the ones that are harder for you. Okay, multiplicity. All right, this function right here, what are its roots? What are the multiplicity at the root? What is the behavior at the root? Okay, so I want to know the root. I want to know the multiplicity. And I want to know the behavior at each root. Okay, so if you think the roots are 7 and -6, you'd be wrong, but if you did, then you'd write it like that, and then you'd say, I think it's a bounce. And I think it, wait, that multiplicity, sorry, that's a number. I think it's a squared, and I think that means bounce. This kind of answer. Try it right now. Pause for a second while you do that. Okay, here's what you should have. Okay, don't break down yet. We're almost done here. Okay, the roots are 6 and -7. Please don't make me call you out. Quiet, please. Almost done. All right, the root of 6 has a multiplicity of what? 2. Okay, and its behavior, a 2, you can just right away go to, oh, I know what 2s do. What do? They bounce. Like bumbles. Remember that from the, yeah, you know what I'm talking about. All right, it's in the Rudolph cartoon that will be coming soon to a TV near you. And now x plus 7, so that's a root of -7, and it does that. Multiplicity 3, and its behavior then is a snake, is correct. Surprisingly enough, the one that people get the wrong the most is the single, because they forget what to call it. A single is a cut through. Okay, if you say multiplicity of 1, that's good, but what's the behavior? You can't be the behavior is a 1. You have to say behavior is a cut through. The word you're looking for is cut through. I would not be able to give you credit for a line. The whole thing is a line. Okay, so what is it doing? What is it doing when it touches? And this one is cutting through. This is cutting through. That's cutting through. Those are all cut throughs. Okay? And cut is fine. I will accept cut. A snake looks like that. Multiplicity is just the, oh, 4. A 4 and a 6 and an 8 all act like a 2. So they would all be bounces. There's only one way to cut through, and that's a single, yes.
So 7 would be
a 7 is like a 3, which is like a triple, which is a snake. Yes, so 7 would also be a snake. We're not going to test you that far. The highest we go is 3, but anyway. Okay. So next, let me see. Oh, yes, one more thing. Let's say I gave you kind of a graphing question that was based on a limit, where I just tell you the limit. You tell me what the graph looks like. The limit of this function as x approaches -3 from the negatives is -infinity. Make me a graph. No, that's not like an R4. That's not that hard, really, if you know how to read these inner limits. You can't know what the whole graph looks like, but you can at least know what some of the graph looks like. Nope. I haven't told you everything. I've told you one thing, so you know something about this graph. Here's what you should have known. Do you agree that x equals -3, the line that would be right about here, and approaching it from the left, the negatives, see, I'm approaching from the negatives, coming from over here, that I have to go towards -infinity, which means I have to do something like that. Now, do I know exactly where it makes that turn? Nope, but I know it ends up going down on that side. Raise your hand if you had that part right. Okay, good. Now I'll give you some more of the picture. Let's say that I say that the limit of the function as x approaches -3 from the positives is positive infinity. Well then, generally as I'm coming from over here on this side, as I get over this way, it's going to force me which way, up or down? Up. There we go. Now exactly where are those lines? Well, what I have to tell you then is what? What would tell you the this way line? Like how do I find that out? Different kind of limit. What kind of a limit? I have to, with the limit, how can I tell you? A left or a right limit. Very good. So the limit of the function as x approaches infinity, that would mean away to the right is 0. So then that tells me a little more about my graph. If I know it's going to get closer and closer to 0 when I go way to the right, then do you get there must be an asymptote line right there? So that line I can tweak a little bit and say, okay, yes, it was going up here, but now I know that it's going to get closer and closer to 0 that way. And then this line I can bring up a little bit and say, okay, it's going to get closer and closer to 0 on that way. Make sense? So how did I tell you that last thing? That the black dotted line here, this one right here, this black dotted line I was telling you by saying this limit right here, the end limit. The end limit tells you what the horizontal asymptote was. Okay. Okay, that's all the review I've got for you. You've got a bunch of time now to work on this packet. I strongly recommend review. If you had to prioritize your life, I'd focus on the graphing questions first because the graphing test is the first one. On Monday, we have the graphing test. Okay? All right. This isn't the cumulative. Remember the communication one is the one where it has all complicated limit stuff on that. The graphing one is mostly about graphing. I'm not saying there's no limits Monday, but they might not ask you to write limits. They might give you limits and say, here are the limits, so you make the graph, because the focus obviously is on making graphs. It is actually, it's not that bad, because then you have 2 days in a row with no homework, and you can split your test into 2 days. Just be happy. You have a choice in life. Focusing on the negatives or the positives. You'll be a lot happier if you focus on the positive things that are happening. Because in a few years, you're going to reach your peak. You're going to be 25 years old and at your physical peak. And after that, it's all downhill. All right, on that happy note.